So our final example of MLlib is going to be using something called term frequency inverse document frequency, or Tf Idf, which is the fundamental building block of many search algorithms. So first, let's talk about the concepts of Tf Idf and how we might go about using that to solve a search problem. Our final exercise with Apache Spark and MLlib is going to be about term frequency inverse document frequency. That's what Tf Idf stands for. As usual, it sounds complicated, but it's not as complicated as it sounds. And what we're actually going to do with Tf Idf is create a rudimentary search engine for Wikipedia using Apache Spark and MLlib. How awesome is that? So let's get started. Tf Idf stands for term frequency and inverse document frequency. And these are basically two metrics that are closely interrelated for doing search and figuring out the relevancy of a given word to a document given a larger body of documents. So for example, every article in Wikipedia might have a term frequency associated with it. Every page on the internet could have a term frequency associated with it for every word that appears in that document. Sounds fancy, but as you'll see, it's a fairly simple concept. All term frequency means is how often a given word occurs in a given document. So within one web page, within one Wikipedia article, within one whatever, how common is a given word within that document? You know, what is the ratio of that word's occurrence rate throughout all the words in that document? That's it. That's all term frequency is. Document frequency, same idea. Named a little bit confusingly, but all it is the frequency of that word across the entire corpus of documents. So how often does this word occur throughout all of the documents that I have, all of the web pages, all of the articles on Wikipedia? Okay, so, you know, for example, common words like a or the would have a very high document frequency, and I would expect them to also have a very high term frequency. But that doesn't necessarily mean they're relevant to a given document. And you can kind of see where we're going with this. So let's say we have a very high term frequency and a very low document frequency for a given word. The ratio of these two things can give me a measure of the relevance of that word to the document. So if I see a word that occurs very often in a given document, but not very often in the overall space of documents, then I know that this word probably conveys some special meaning to this particular document. It might convey what this document is actually about. So that's Tf Idf. It just stands for term frequency times inverse document frequency, which is just a fancy way of saying term frequency over document frequency, which is just a fancy way of saying how often does this word occur in this document compared to how often it occurs in the entire body of documents. That's all Tf Idf means. It's that simple. So in practice, there are a few little nuances to how we use this. For example, we use the actual log of the inverse document frequency instead of the raw value. And that's because word frequencies in reality tend to be distributed exponentially. So by taking the log, we end up with a slightly better weighting of words given their overall popularity. And there are some limitations to this approach, obviously. One is that we basically assume a document is nothing more than a bag full of words. We assume there are no relationships between the words themselves, and obviously that's not always the case. And actually parsing them out can be a good part of the work because you have to deal with things like synonyms and various tenses of words, abbreviations, capitalizations, misspellings. You know, this gets back to the idea of cleaning your data being a large part of your job as a data scientist, and it's especially true when you're dealing with natural language processing stuff. Fortunately, there are some libraries out there that can help you with this, but it is a real problem, and it will affect the quality of your results. Another implementation trick that we use with Tf Idf is instead of actually storing actual string words with their term frequencies and inverse document frequencies, to save space and make things more efficient, we actually map every word to a numerical value, a hash value we call it. So the idea is we have some function that can take any word, kind of like look at its letters, and assign that in some fairly well-distributed manner to a set of numbers in some range. So that way, instead of using the word represented, that might have a hash value of 10. And we can refer to the word represented as 10 from now on. Now, if the space of your hash values isn't large enough, you could end up with different words being represented by the same number, which sounds worse than it is. But you want to make sure that you have a fairly large hash space so that that is unlikely to happen. Those are called hash collisions. and they can cause issues. But in reality, there's only so many words that people use in the English language commonly, so you can get away with 100,000 or so and be just fine. All right, and obviously doing this at scale is the hard part. If you want to do this over all of Wikipedia, then you're going to have to run this on a cluster. But for the sake of argument, we're just going to run this on our own desktop for now, using a small sample of Wikipedia data. So how do we turn that into an actual search problem? So once we have Tf Idf, we have this measure of each word's relevancy to each document. What do we do with it? Well, one thing you could do is compute Tf Idf for every word that we encounter in the entire body of documents that we have. And then let's say we want to search for a given term, a given word. Let's say we want to search for what Wikipedia article in my set of Wikipedia articles is most relevant to Gettysburg. I could sort all the documents by their Tf Idf score for Gettysburg and just take the top results. And those are my search results for Gettysburg. That's it. Just search. Take your search word, compute Tf Idf, take the top results. What documents have the highest Tf Idf score? That's it. Obviously, in the real world, there's a lot more to search than that. Google obviously has armies of people working on this problem, and it's way more complicated in practice, but this will actually give you a working search engine algorithm that actually produces reasonable results. So let's go ahead and dive in and see how it all works. So there you have the concepts of Tf Idf, another one of those things that sounds really fancy, but once you understand it, it's actually quite simple. So let's go ahead and turn that into actual source code and run it in our next lecture.